Okay, today you're solving the system of equations, but got a little problem. I mean, here's the first problem: 3x plus 3y equals 27. Then x minus 3y equals negative 11. So we need to find where the x and the y would come together. But you got a little problem. I don't see a letter by itself, either x or y, so there's no base. So we need a new method. So when I don't have a base, I'm going to write down the first equation down here for later. That's like in your back pocket for later. You'll need it later, but now come back up to the two equations. You're going to use a process known as elimination. And here's how this is going to work. You're going to kind of organize your x's and y's into columns, and then this gets its own column here. But what has to happen is we need to add the equations, and either the x's or the y's have to add to 0. Okay? So if I put a 1, 3 plus 1 is not 0. Okay? So the x's don't add to 0. But let's look at our y's. If I would take 3 plus negative 3, I'm adding opposites of the same number, a positive and a negative. That's 0. Okay, so I got 0y, and that's good. Then I can add the rest of this. So that's 4x. And equals, after the equals, we take 27 and add negative 11, which is 16. So what's the point of that? Well, guess what? When you have a variable with a 0, it's gone. It vanishes. It doesn't need to be there. So we have 4 times x equals 16. Well, then I divide by 4, and I have my answer for x over there. X equals 16 divided by 4, which is 4. So I have my x answer right here. Now to find y, this is why we wrote down that first equation. Now you could write down the first or the second. It doesn't matter. I usually write the first. 4 goes in for x, so that now I can figure out what y is. So 3 times 4 is 12. Plus 3y equals 27. So there's your multiplication. You take out your 12. 27 minus 12 is 15. Then you divide each side by 3. And 15 divided by 3 is 5. Okay. And you could use that one too. I usually just normally pick the top. Do everything right, you're going to get the same answer. Alright, negative x plus 5y equals 13, and then x minus y equals 15. So I have to find the x, y, where they cross. Okay, well I don't have a base here either, so no base, so I'm using this new method. So negative x plus 5y equals 13. If you want to put the 1 right there, you can. You can even make that a negative 1 if you want. Okay, now let's organize the x's into columns. Okay, you can do that. Okay, I didn't line up the equals very well on this, but it's still fine. Okay, so I put 1's right there. Okay, and the y's, we got a 5y and a negative 1y, and then we got these 13 and 15 outside. Now the x's and the y, and we're always adding. Okay, we're never minusing. So if I go negative 1 plus 1 for the x's, that's 0, so I have 0x. Then I keep, since I got that to be 0, I keep going. 5 plus negative 1 is 4y, and then equals 13 plus 15 is 28. So 0 can take out the x. Anything times 0 is 0, so even though I don't know what that letter is, okay, or what that letter, the value for that letter, I can cross it out. So divide by 4, 28 divided by 4 is 7. So y is 7. Now you're going to find your x by taking the 7 you just got and putting it in for the y. And then you could take 5 times 7, that's 35. Now you'd still got your negative 1x, but you're going to add 5 times 7, which we know is 35, equals 13. Now you solve for x, so you subtract 35 from each side. 13 minus 35 is negative 22, so negative 1 times x equals negative 22. and then you just divide by your negative 1. And that's positive 22. And you found it, 22 and 7. Okay, next problem. 2x plus 4y equals 22. 2x minus 2y equals negative 8. So again, I have to find the point of intersection, the point that belongs to both equations. Okay, no base there, no base there. Alright, so write down your first equation, that's for later. Alright, now let's see if we can get either the x's or y's to add to 0. So 2 plus 2, no, that's 4. 4 plus negative 2, that's going to be 2. So I can't get anything to add to 0 right now as it is. Well, I need to make a change then. Do either x's or y's have the same number in front? Yeah, right there. So you write the word same. And what you do with the same is you're going to actually make this equation on bottom into the opposite, which you're allowed to do, as long as you make everything opposite. So what's the opposite of positive 2? Negative 2. I usually do the bottom, I don't do the top. Opposite, I leave the top the way it is. You have to do one or the other, don't do both of them. Opposite of negative 2 is positive 2, opposite of negative 8 is positive 8. Now, 2 plus negative 2 now adds to 0, so we now have 0x. And now 4 plus positive 2 is 6y. 22 plus positive 8 plus 8 is going to be a 30. Then 0x goes out. So I got 6 times y equals 30, so I divide by 6. And 30 divided by 6 is 5, so y is equal to 5. Now, 5 goes in for y in this equation I wrote here, because now I'm going to solve for x. 4 times 5 is 20. You're always times in those numbers, because 4y means 4 times whatever y is, but now that I have the number for y, 4 times 5 is 20. Equals 22. So you take out your 20. So that would take that side to 2. 2 times x equals 2. Then you divide by 2, and x equals 1. 5. Okay, next problem. 4x minus 7y equals 3. And then x minus 7y equals negative 15. So don't have anything by itself there or there, so there's no base. Okay, so write your other equation, 4x minus 7y equals 3. We'll make that plot. You're just copying it down. Now let's see if either the x's or the y's can add to 0. Over there doesn't really matter. Okay, I mean I'll end up adding them, but I don't care if these add to 0. Okay, so 4 plus 1, that's 5. Okay, so I don't get 0 there. Remember, I don't write 5 down. Okay. Now I take negative 7 plus negative 7. That's not 0 either. To get it to be 0, one has to be positive, one has to be negative. Okay, so we don't have a 0. But we do have the same term right there. So we're going to make the bottom opposite. So negative, positive, positive. Notice how I don't write anything down until I know for sure that I get a 0 there or there. We're always plussing, okay? Always plussing. 4 plus negative 1 is 3. Negative 7 plus 7 now is 0, just like I told you it would be. If you have a positive and a negative of the same value, and then 3 plus positive 15 is 18. So, Mr. Y, you're out. Okay, so I now have 3 times x equals 18. So I divide by 3, and x equals 6. Okay, now I've solved for y. 6 goes in for x into that equation I wrote down. See, I like it there, so I can just go into it then. Okay, you are multiplying 4 by 6. That's 24. And then you have plus negative 7y equals 3. So here's the multiplication of the y. You got to take out your 24 by minusing 24. So we have negative 7 times y. 3 minus 24 is negative 21. And then finally I can divide to figure out what y is. Y is 3. So 6, 3. Okay, last two. 5x minus y equals 0. And then 3x plus y equals 24. 5x minus y equals 0. 3x plus y equals 24. Okay, so I have to find the x and the y. Well, I don't have a letter out front by itself there or there, so I guess we have to use a different method. So write down your 5x minus y equals 0. That'd be a 1 with a negative. And then organize your x's and y's together, okay? And then see if you can get them to add to 0. Well, 5 and 3 doesn't add to 0. That's 8, okay? Now, negative 1 and a positive 1, is that going to add to 0? I think it does. I mean, it's a negative and a positive of the same number. They should always plus to 0, which they do. So I have my 0 there. Now I write down the rest of it. So that's 8x equals 0 plus 24 is 24. See you, Mr. Y. And now we have 8 times x equals 24. So divide by 8. 24 divided by 8 is 3. Now to find y, 3 goes in for x. So we need to take 5 times 3, that's 15. Then we add our negative 1y equals 0. Wall, there's the multiplication. Got to take out your 15 by minusing 15. Remember, when you have 0 and you're taking away a number, it just ends up being the negative of that number. And then you divide each side by negative 1. Negative divided by negative is a positive, so that's going to be 15. Okay, then our final problem. I don't know if I wrote that down right. I need to check it. No, I did not write this down right. Okay. The problem is 6x plus 5y equals 39, and then 3x plus 5y equals 27. 6x plus 5y equals 39, 3x plus 5y equals 27. Okay, so I line up my coordinate. Now I decide the method. Obviously, we're not going to be able to pick a base letter, not with anything by itself. Now, is it possible to get a base letter? Yeah, but it's a waste of time when we have this way. Okay. So 6x plus 5y equals 39. Then I organize my columns, and I see if either the x's or y's plus to 0. That's 9x, and that's 10y. So they're not going to plus to 0 now. But I do have the same in that column there. So if I went opposite along the bottom, then I'd have a positive and a negative of the same thing, which means I would add to 0. So opposite of 3 is negative 3, opposite of 5 is negative 5, opposite of 27 is negative 27. So now I do my adding. 6 plus negative 3 is 3. That is still not 0 there. 5 plus negative 5, bam, 0. So 0y. And then we got 3 over here. And then 39 plus negative 27. Remember, your 27 is negative. It's 12. See ya, Mr. Y. And now we have 3 times x equals 12. So I divide by 3. And 12 divided by 3 is 4. X equals 4. Now, 4 goes in for the x. And that enables me then to find my y. I take 6 times 4, that's 24, plus 5y equals 39. Remember, don't put 24x. X is gone. Okay, when the 4 goes in for x, the x is history. Now, minus 24, minus 24. You now have 5 times y. 39 minus 24 is 15. Then divide by 5, and y equals 3. 4, 3.